Hi! The cash flows you see on the timeline are the same cash flows we saw when we calculated the net present value of the teddy bear producing factory a couple of videos before. And as a quick recap, when calculating the net present value, we applied the concept of value additivity, which in plain words stipulates that the value of the whole, and in this case the whole is a project, is equal to the sum of the values of the parts, and the parts are the individual cash flows that make up the project, the cash flows that you can see on the timeline. So in other words, the net present value equals the sum of the present values of a series of cash flows. Now what we want to do in this video is express a general formula that, if applied, will allow us to reach the net present value. Before doing that, I'll introduce the summation symbol because I want you to try to arrive at the formula on your own before watching me express it. So in mathematics, we use this symbol to denote summation, and this is the Greek capital letter sigma. For example, this expression, which is read as sigma I equals 1 up to 100, is a compact way of saying 1 plus 2 plus 3, and so on and so forth, all the way up to plus 100. Now that we introduced that, can you think of a general formula that will give us the net present value? What we basically want is a formula that will discount all the cash flows on the timeline to take them back at time 0 and then sum them up. Just pause the video, write down your formula, and then compare it with mine. Assuming you did that, the net present value equals sigma, because I want to sum a bunch of cash flows, from t equals 0 up to uppercase T, where I use uppercase T to denote the point in time that the last cash flow will occur. And in this example, that point in time is year 3. Now what's left is the term within sigma, and that term is cash flow subscript T over 1 plus R to the tth power, because I want to discount the individual cash flows and then add them up. So this is the formula, a rather simple one. Let's see if it works by applying it within the context of this problem. Let's expand the formula based on the project's cash flows. So net present value equals cash flow 0 over 1 plus R to the 0th power. I'm not doing anything complicated over here. I'm just applying what the formula stipulates, starting with the cash flow at time 0. Now plus cash flow 1 over 1 plus R to the first, plus cash flow 2 over 1 plus R squared, plus our final cash flow, which is cash flow 3 over 1 plus R to the third. Now let's replace our cash flows and R with their actual values. This gives us minus 10 over 1.1 to the 0th. Remember, any number raised to the 0th is 1, so this is just minus 10 over 1, plus 3 over 1.1 to the first, plus 5 over 1.1 squared, plus 7 over 1.1 to the third. And this is exactly what we did a couple of videos before to arrive at the net present value. This equals minus 10 plus 2.73 plus 4.13 plus 5.26 for a final value of 2.12 million euros. So our formula works just fine. If you have any doubts as regards the validity of a formula, I encourage you to rewatch the second video on net present value and value additivity and convince yourselves that our formula over here allowed us to arrive at the same result. And it makes sense actually, because as I said before, this formula performed the exact same calculations. Before I close this video, I'd like to say that you might see this formula, say in a textbook, expressed in a slightly different manner. The end result you will get though will be the same. You need to realize that what's important is not how the formula is expressed, but putting yourself in a position where you understand what's going on in a given problem. You basically need to be able to identify when a cash flow should be included in the calculation of the net present value and what sign it should have. That is, whether it is a cash inflow or a cash outflow. As long as you do that, it doesn't really matter how the formula is expressed.